of Science and Tech, National States, the representative of the Executive Secretary of TEDFON, the CMD of Federal University Teaching Hospital, Lafia, the Rector of Mr. Abubakar Polytechnic, the Provost of Federal College of Technical College of Education, Kiana, and the Provost of College of Art and Science of Lafia, Dr. Lekefi, the representative of our Senator, Aliyu, the chairman of Committee of Deans, Provosts and Directors of Federal University of Lafia, Deans, Provosts and Directors, heads of departments, and other members of Senate of Federal University of Lafia, the heads of security agencies in national states, the inaugural lecturer, his family and associates here present, staff and students of Federal University of Lafia here present. I welcome all of you. It is with great pleasure that I welcome you all to Federal University of Lafia. I begin this address by expressing my sincere thanks to all of you for attending this inaugural lecture titled Sustainable Nuclear Radiation Attenuating Materials Towards the Polarization of Nigeria's Mineral Resources by a professor of nuclear physics, Professor Abubakar Sadiq Aliyu. The presence of all of you here today as our guests is an expression of great support to this university. Inaugural lectures are formal academic events where newly appointed professors present their work and research to the university community and the public. Originating at the University of Oxford in 1623, these lectures serve as public declaration of professors' stewardship and future research plans within their field of study. Inaugural lectures also provide a platform to discuss the state of a discipline, its challenges, and its contribution to the academic curriculum. This cherished academic tradition has been neglected or ignored on a regular basis in many universities, to the extent that some professors retire without giving their inaugural. In Federal University of Lafia, we have developed inaugural lecture policy to sustain inaugural lectures and ensure that within 2 or 3 years of being given a chair or becoming a professor, every professor shall deliver his or her inaugural lecture. This is the best practice globally. Today, Professor Abubakar Sadiq Aliyu is presenting the first inaugural lecture from the Department of Physics and the first in the newly created Faculty of Physical Sciences of this university. It is an opportunity for this distinguished scholar to share his knowledge, discoveries, and even personal journey in the field of nuclear physics. We are all here to celebrate him and learn from his vast knowledge and experience. I therefore congratulate Professor Abubakar Sadiq Aliyu and the Department of Physics and Faculty of Physical Sciences on this achievement. From the title, we shall be enlightened on how researchers are exploring the use of natural materials to create effective and sustainable radiation shielding solutions. I expect all of us to be more attentive and learn some good lessons from this lecture. Professor A.S. Aliyu is a very hard-working academic. I have seen him hold several positions in Federal University of Lafia. I'm aware I indeed witnessed his excellent performance as HOD of Physics and Director of Muhammad Buhari TEDFON Center of Excellence in this university. Congratulations once again on your inaugural lecture today. On behalf of the university management, I express our deep appreciation to the University Inaugural Lecture Committee, which has Professor Josephine Ode as chairperson, for the progress we are making in our inaugural lecture series. Let me also thank Professor A.S. Aliyu's family and his associates for the support given to him during his academic journey and during the preparation for this inaugural lecture. I welcome you all and best regards. Thank you very much.
Present, in order not to fall into error of omission of protocol, I want to respectfully stand with already established protocols. May I please invite Professor Abubakar Sadiq Aliyu to rise and remain standing for his citation. My Vice Chancellor, sir, ladies and gentlemen, esteemed colleagues and honored guests, it is my pleasure to introduce to you Professor Abubakar Sadiq Aliyu, a celebrated scholar and expert in the field of nuclear physics. Abubakar Sadiq was born in late October 1982 in Angwaremi, Kefu. He began his educational journey with Islamic study under the guidance of his father, later enrolling in formal education. He attended Baptist Primary School, Kefu, obtaining his first school leaving certificate in 1995. Professor Aliyu obtained his Bachelor of Science degree in Physics from the National State University, Kefu in 2007, where he emerged as the best graduating student in the Department of Physics. He followed his education with a Master of Science degree in Radiation and Medical Physics from the Benue State University in Makurdi in 2012. His PhD research earned him a Doctor of Philosophy in Physics from University Technologia Malaysia, UTME, in 2014, where he was honored with the Best Student Award. Professor Aliyu's academic career spanned over a decade with a strong commitment to teaching, research, and mentorship. He began his academic journey as a graduate assistant in training at the National State University, Kefi, in 2008, and progressed to become a senior lecturer at the Federal University of Lafia in 2016. His expertise and contribution to the field of nuclear physics earned him the appointment as an associate professor of nuclear physics in 2019, and he has been serving as a professor of nuclear physics at the same institution, Federal University of Lafia, since 2022. Professor Abubakar Sadiq Aliyu has received numerous scholastic honors throughout his academic career, some of which include the Best Student Award for Doctor of Philosophy Physics at the University Technologia Malaysia. Also took his new Best Student, Faculty of Science in 2005 with the highest CGPA, and Best Graduating Student in the Department of Physics at the National State University, KV, in 2007, and many others. In addition to this award, Professor Aliyu has received various certifications in recognition of his contribution and participation in academic and scientific events. Throughout his career, Professor Aliyu has demonstrated a remarkable ability to balance teaching, research, and community service. His research interests are diverse, encompassing nuclear physics, radiation protection and safety, nuclear security and safeguard, and environmental radioactivity and health physics. He has published close to 50 articles in reputable Q1 and Q2 journals, including the Journal of Environmental Radioactivity, Radiation Physics and Chemistry, and the Journal of Nuclear Science and Technology. His articles are cited in both Thomson Reuters' work for science and Elsevier scholars. Professor Aliyu has secured several research grants, including TEFRON's National Research Fund 2021, which have enabled him to conduct cutting-edge research and collaboration with international experts in this field. As a dedicated mentor, he has supervised and currently supervises numerous postgraduate students, including 5 PhD and 9 master's students, many of whom have gone on to become successful professionals Professor Aliyu has served as a standard examiner for postgraduate students at Nelson Mandela University, South Africa, University of Johannesburg, South Africa, and the Ahmadu University, Zaria, and Usman Fodio University, Sokoto. Professor Abubakar Sadiq has widespread experience in university administration, having held various positions and served on various committees, notably as director of the Mohammed Buhari Teflon Center of Excellence at Federal University of Lafia from 2023 to 2025, and previously as acting director in the same center from 2020 to 2023. Faculty Postgraduate Coordinator or representative of the Faculty of Science to the School of Postgraduate Studies Hall, head of the Department of Physics from 2017 to 2021, and acting head of the Department of Geology from 2018 to 2019. Professor Aliyu has served on various committees, including chairing the committee to interact with Solar Shelter Company on their proposal for electric transportation, and the project commissioning committee for the second, third, fourth, and fifth combined convocation program of the university, School of Postgraduate Studies Examination Vetting Committee, ad hoc committee on the partnership between Federal University of Lafia and Technology Incubation Center, and many others. Professor Abubakar Sadiq Aliyu is a distinguished member of several prestigious professional bodies, including the Health Physics Society, International Union of Radiology, World Institute for Nuclear Society, and the Nigerian Institute of Physics. He also served as contact person from Nasarawa State University, Kefi, at the International Nuclear Security Education Network, initiated by the International Atomic Energy Agency. Professor Abubakar Sadiq Aliyu has attended several international meetings and professional development courses that showcase his expertise and commitment to nuclear security and academic excellence. He participated in the International Conference on Nuclear Security 2024, organized by the International Atomic Energy Agency in Vienna, Austria. Additionally, he has attended annual meetings of the International Nuclear Security Education Network, organized by the same body in Vienna, Austria in 2016, 2017, 2018, and 2024. In terms of professional development, Professor Aliyu has attended various training courses and workshops, including the regional training course on quality management system at the Ghana Atomic Energy Commission Accra in 2023, a capacity building workshop on enhancing capacity of doctoral supervisors organized by the Doctoral Academy of Nigeria down in Abuja in 2021, and a training of trainers in research project management and writing skill organized by the Tertiary Education Trust Fund in Dubai in 2022. He also attended an introduction to nuclear security course at the International Atomic Energy Agency in Vienna, Austria in 2016, and a two-day workshop on academic excellence for younger academics at Nasarawa State University, Kefi, in 2015. As a desk officer for the Tertiary Education Trust Fund at Federal University of Lafia, Professor Abubakar Sadiq Aliyu played a crucial role in facilitating the disbursement of intervention funds to the university. His responsibilities include liaising with that fund for all categories of intervention and consulting with the organization to keep the university up to date on all guidelines for assessing intervention funds. He also facilitated the implementation of various projects and intervention, including training of over 90 academic staff for PhD and master's degree, as well as bench work in foreign and local institutions under the Academic Staff Training and Development Program. Professor Aliyu also oversaw the implementation of various physical infrastructure projects, including the construction and furnishing of the Adamu Office and Lecture Complex, Mohammed Buhari Institute for Research and Training, Faculty of Agriculture, Center for Entrepreneurship Development, Faculty of Science Annex Building, Faculty of Arts Annex Building, Science Laboratory Complex, and Visual and Creative Arts Studio. Furthermore, he facilitated the implementation of various zonal interventions, such as the construction of male and female laboratories at the permanent site, procurement of a brand new 33-seater bus, procurement of vehicles, and many others. Under 10th Special Intervention Project, Professor Aliyu facilitated the construction and furnishing of a multi-purpose hall with the Directorate of Management Information System, the venue of this inaugural lecture, and other associated projects. Professor Aliyu played a key role in the implementation of special high-impact projects, including the construction and furnishing of the administrative building, Faculty of Environmental Sciences, and many others. Today we gather to celebrate Professor Aliyu's ascension to the professorate and listen to his inaugural lecture, a milestone that marks his outstanding contribution to the field of nuclear physics. Ladies and gentlemen, please join me in welcoming Professor Abubakar Sadiq, the professor as an individual in the Professorial Inaugural College of Federal University of Lafia.
Thank you very much. Our indefatigable university orator, the Vice Chancellor, Federal University Lafia, who doubles as chairman of this occasion, Professor Shehu Abdurrahman, members of the university management team, visiting professors, head of institutions, royal fathers here present. Vice Chancellor, sir, please permit me to stand on the already established protocol. I would like to, as requested by the protocol officer, recognize some visiting colleagues from the Abubakar University. Professor Babawala Shaibu, Dean Faculty of Technical Education, ATB. Professor Aliyu Ibrahim, Patron in Vocational Education, ATB. Professor Ahmad Aliyu Deba, Head of Department Electrical, Electronic, Technical Education, ATB. And I also have my secondary school mates that are here with us, architect Hassan Mustafa, Ada Shaibu, Mr. Emmanuel Mweke, Mr. Obasani Michael. You are all welcome. Thank you very much. Without wasting much of your time, Vice Chancellor, sir, the title of today's inaugural lecture is Sustainable Nuclear Radiation Attenuating Materials Towards the Valorization of Nigeria's Mineral Resources. It is the 31st in the series of the lecture, the inaugural lecture of this university. To give my audience a sense of continuity and understanding, I have included from the title page of this lecture some very important photos. On the left-hand side of the screen, there are some circular disc-looking materials there. It's a photo of nuclear radiation sources, and they are labeled appropriately. On there, the greenish top is plutonium-210, which decays by emitting alpha radiation. Strontium-90 decays via the emission of beta radiation, and cobalt-60, it decays via the emission of alpha radiation. The right-hand side of the screen is a fully geared man in protective gear who is supposed to be working with these high-level radioactive materials. Now, that is an important foundation for today's lecture. The clothing the person is wearing that are made from specially engineered materials or fabric that are meant to protect the person from the effects of exposure to nuclear and ionizing radiation. Okay, so the outline of this presentation, which should take us less than an hour, we will look at some introduction, talk about radiation shielding, the concept, and then talk about the market opportunity. Then introduce the new emerging technology like sustainable radiation materials, and then discuss Nigeria's potential in becoming a hub for original hub for the production of radiation shielding materials. And then we shall look at this our own research, my team research producing radiation shielding glasses, multi-layer. Then we'll look at our own research on multi-layer space radiation shielding solutions, and okay. So then look at the opportunities for investment, then propose some policy recommendation before conclusion. Why is sustainability central to this theme? By sustainability, this lecture will highlight our focus on environmentally friendly materials, resource conversion and conservation, and then the potential for future generation. And this aligns with the United Nations SDG number 12, number 14, and 15 promotes the protection of marine and terrestrial ecosystem. Humans are continuously exposed to radiation. As we are sitting here, we are in the field of radiation, but we do not have the sense of taste or seeing or smelling to smell this radioactivity. It is part and parcel of us, but it becomes dangerous when you are exposed to high level radiation. So our exposure is with or without our consent. And if you take a flight from here to, let's say, China, you will become exposed to higher levels of radioactivity because of the cosmic rays or cosmic particles that are coming from the space. This radiation we are speaking about is a form of electromagnetic energy that is even here with us. The visible light, the light that you are using here, is a form of radiation. But radiation is characterized into two: the ionizing and non-ionizing radiation. I have on the right-hand side of the screen a picture depicting the classification of radiation. One, on the blue side, you have non-ionizing radiation, like microwave, radio wave, you use for signal transmission, ultraviolet UV. This is non-ionizing. And on the right side, there is ionizing radiation coming majorly from the X-ray machine we use in hospital to study human physiology. And then you have radioactivity coming from the nucleus of certain elements. That's why I gave you strontium-90, polonium-10, 210, and cobalt-60. These are radioactive elements. So this class of radiation, they are coming from the nucleus, and it is either, they are classified as either gamma, alpha, gamma, or beta radiation. Then the neutron too is a form of radiation from the nucleus. But the classification of radiation into ionizing and non-ionizing radiation is based on the fact that certain type of radiation will knock off electrons from the atoms of the materials they interact with. That is where the word ionizing radiation comes from, the ability to remove electrons. And that will change the chemical and even the physical properties of the material. Now, the exposure to ionizing radiation in human is something we are concerned with, because if human is exposed to radiation, it is either the effects is direct action or indirect action. In the direct action, the radiation goes into the cells and destroy the DNA. In the indirect action, you have formation of free radicals that will disbalance the chemical stability of the cell, and thereby distort genetic information, and cause chromosomal aberration, and even mutation. So, in terms of sustainability, no. Toxic to environment and toxic to human is poisonous. It is heavy and it is expensive. Why we are emphasizing on the weight, heavy, because if you are to propel a satellite to the space and you are using heavy material, you will need more money to design the space shuttle, and also more money on the fueling, because it is a heavy vehicle that is sending to space. Thus, we need sustainable, inexpensive substitute to lead in aspect of radiation shielding or radiation attenuation. I put it here a story, negative story from the website of the American Center for Disease Control on what happened in Nigeria in the year 2010, where hundreds of children died in Zamfara State as a result of accumulation of lead, because the local artisanal miners there were using the stream to wash off gold. This gold mining has been in Zamfara, has been there for long. And what happened was that the pointer that the epidemiologists should have used was the sudden disappearance of ducks. Our were disappearing. That should have been a pointer to some type of environmental hazard, but that clue was misunderstood until he killed almost 200 children. Because when you have chemical exposure in adults, the effects is more, the medical doctors are here, is more discernible in children than in adults. You will lose over 200 children as a result of lead exposure to lead from mining of gold. And so that is a negative. So just to establish why we need sustainable, environmental or eco-friendly radiation shielding materials. Now, the increasing unsustainable radiation shielding materials, increasing demand for eco-friendly shielding and substitute for toxic lead has boosted or motivated researchers to begin to invest money and time into research for alternative materials. And the advancement in composite material synthesis, like where you use polymers and so on, is also a major research we have explored. Vice Chancellor, sir, as we proceed into this lecture, I will share with you the knowledge, myself and my team, which the member of the team, most of them are here sitting with us. We produce multi-layer shielding solutions for development of space shuttle and spacecraft using polymer ceramic composite. And some of their works are cited in the handbook, which I will guide you to the references. Now, before we go into our own work, let's look at the potential that is lying there for Nigeria. Key minerals that are currently used or researched as substitute for the toxic leads are bismuth oxide, tungsten oxide, barium, hafnium, and so on. I included on that slide some pictures of bismuth ore, tungsten ore, and barium. Most of these minerals are available in large quantity in Nigeria, but it would be that they are either underexplored or we do not have the political will to pursue the utilization of these materials for our own good. In terms of bismuth reserve, Nigeria has various deposits of bismuth in various locations, like the one we sourced from Railway in around Kano State. Another study by reference number 13 revealed that many of the minerals that were studied by that reference number 13 revealed that they contain 30 to 45 weight percentage of bismuth. But in our own case, we conducted a mineralogical characterization of two mineral ores sourced from Falgore Forest in Kano, that is the bismuth ore, and tin ore from the Jos Plateau. What we discovered that the bismuth clay we got from Falgore Forest has 80 weight percentage of bismuth. So the impurity in it is about 20%. while the tin we got from Jos Plateau, which has been a hub for for mining of tin for almost 5 decades, contains about 70 weight percentage of tin. Just about 30% of the ore is made of other things. Some of the things that are contained in those ores were copper, vanadium, aluminum, which are also useful. Despite the global growing interest of use of bismuth in radiation shielding, and the business opportunity there is no available data to public on bismuth reserve and the market opportunity on the federal government and state government websites. This has to be corrected. As for tin mining has been done around Jos Plateau for almost 40 to 50 years. The government website shows that Nigeria's reserve is over 30,000 tons, and the markets that were the generated fund for 2022 for tin is about $280 million. I still doubt the authenticity because it could be that this is grossly underreported. On that slide, I put a picture of the bismuth and tin ore we have investigated using our mineralogical characterization techniques. Okay. Another mineral ore that could be used for lead as not substitute to lead is tungsten. The Afro-Younger granite, Afro, from Kokona local government, that's how geologists label that the rocks, maybe granite from that place, has been reported to contain 168 part per million of tungsten, which is greater than the 1.25 to 1.5 part per million global average for tungsten. In 2023, Nigeria exports for tungsten was just about $1 million, despite having one of the highest concentration globally. We need to promote domestic processing of these mineral resources. Hafnium is found, another mineral is hafnium. It is found in association with zirconium. Nigeria's deposit for zirconium is around Borno, Yobe, and Adamawa. We could also extract or process hafnium from our zircon deposit. We therefore need to encourage domestic processing of these minerals ores in order to produce radiation shielding for our country. The next, Vice Chancellor, the next aspect of the lecture is our research program. We produce, so the next one is radiation shielding glasses using the mineral ores we have characterized. We produce glasses doped with the bismuth and tin ores for radiation shielding applications. But before we produce the glass, we need a glass former. And the glass former we use for the production of this glass is silica. Silica sourced from rice husk, which is another major environmental or agricultural waste. So we were able to calcine rice husk after purification process to extract ashes from them and then see the amount of silica we can extract from that rice husk. But in order to do comparative analysis, we say, okay, another major source of silica that has been reported in literature is a palm fruit bunch fiber. We have palm fruit available in Nigeria, so we also source palm fruit and then do chemical leaching, chemical treatment to produce silica from the two sources. On the bottom side of the screen, there are two types of ashes there, the white one and the dark one. The white one is rice husk ash, while the dark one is the ash from palm fruit bunch fiber. And we conducted X-ray fluoroscopy and other types of experimental tests on these ashes to see the amount of silica which we need for glass engineering in them. And it was revealed that 97% of the rice husk ash is silica. Even the chemical shelf or the market silica that you will buy online maybe contain about 98%, which is, you have to import it. But we extracted 97% purity silica from rice husk, while the palm bunch fiber contain ash, contain about 80% purity. The disadvantage we had with palm fruit bunch fiber is that the yield after boiling, if you put 100 grams into calcination process, you only extract 10%. That is 10 grams of ash. But rice husk, if you put 100 grams of it and burn it to ash it, you'll be able to get 20% or 20 grams of ash or silicon. So that informed us to make sure that we use rice husk for the glass fabrication, so that we will save energy in the process too. My team and myself were able to produce 4 series of glasses for the purpose of radiation shielding. Do not be bothered with the chemical formula there. What I want you to concentrate on is the red and blue ink there. The red and blue ink are labels for the chemicals like SI, the 3O, and so on. So the first glass series contain silica from rice husk, and then the glass was doped with tin O and bismuth O. The second glass series we produced was, we also used silica from rice husk, but we doped the glass with only bismuth O. In the third glass series, we now change the source of silica and use glasser, quartz, source courtesy of Dr. Degree from the Department of Geology. We sourced it from a borehole well that was drilled in Shabu to collect a glasser and use that same glasser for the production of radiation shielding glasses. That was doped with bismuth O. The last glass series was that of broken recycled glasses. We collected broken glasses and then recycled it to produce the radiation shielding glass. Now let's go into the laboratory of peripheral. On the top side of the screen there, you have pictures of the glasses. The first series, that's what series 1, with rice husk and bismuth O. Now you have 6 glasses. The first glass has no bismuth and tin. It is pure rice husk silica. While we continue to increase the percentages of bismuth and tin in the glass, that's why you can see they are becoming darker and darker. Now, in order to ensure that we produce glass, we conducted X-ray diffractometry on the glasses to see whether it is amorphous or crystal in nature. And we found only a little nanocrystal in them. So 90% of the glasses was amorphous. Now, the third picture there was a laboratory setup we used using our mobile X-ray machine to generate X-ray and put a detector below the X-ray tube and in position put the glass. We measure the energy or the dose delivered to the detector without the glass, and then put the glass in position to see. So that we'll be able to know, are these glasses attenuating the X-ray? And the next picture, we have to use sources, radiation sources, the ones on the first slide. Because in X-ray you need to plug, you need electricity, you need this. But with radioactive sources, it is spontaneous. You don't need electricity. So we set up an experiment at the Center for Energy Research and Training of Ahmadu Bello University, Zaria, for the second experiment with gamma sources, gamma radiation sources. What we discovered that was exceptional. In order to characterize better in terms of the radiation attenuation properties, we also collaborated with Dan Dash, the Arab hospital in Lafia, to collect part of the shielding glasses that they have been using in their scope. Take a part of it and then use it in the same experiment in order to establish whether, that is why there is a last glass there, the last on the figure there is the lead barium glasses imported. I think they've imported it from the US. Our glasses outperformed the one we sourced from the manufacturer. Because we got lower mean free path, mean free path. Our aim for X-ray attenuation was lower. We took the same glasses to our Center for Energy Research and Training in ABU to use with gamma radiation, and our own glasses still outperformed that of the imported glasses. Vice Chancellor, sir, our results for characterization of Series 1 glasses are published in references in the book 3 and 4, and the glasses exhibited improved density with addition of bismuth and tin holes, and the glass demonstrated superior gamma and X-ray shielding with improved attenuation coefficients, mean free path, and half-value layers. These are all science done. For the series number 2 glass series number 2, we only use bismuth O. We did not include tin in the glass fabrication. You see, these are looking more of ceramic in nature, but we also had to do X-ray diffractometry on it to see the crystallinity in the glasses. This glass also was emerged as a promising candidate for lead-free attenuation and potentially safer and more environmentally friendly. The third series of glass, where we use quartz, and that's a glass sourced from Chabu in Lafia here. This is the best glass so far because it is transparent. Those ones were dark. This is transparent. If you want radiation shielding glasses, that is why the X-ray operator will hide behind one door and say, put your chest very well, because there is a glass window the person is looking through. That glass window is not ordinary glass. It is a glass that has the ability to attenuate the X-ray that is being generated from the machine. So this glass is the best because of its transparency and also the radiation shielding attenuation. On that table, you see I sampled something. 25. The glass number with 25 weight percentage of bismuth O. It has mean free fat of 3.73. While the commercial one that we source from the Lafia Hospital has mean free fat of 9.2. In terms of mean free fat, the lower the mean free fat, the higher the attenuation. So the best glass there was the last glass, the fifth one, with 25 weight percentage of bismuth O in it. The next, last but not the least glass, was a glass we produced from broken or recycled glasses. And we doped that glass with tin O and barium sulfide. This glass, the results of the characterization of Series 4 glass has been published in reference number 7. It also demonstrated exceptional shielding, radiation shielding properties. Now, as for the impacts of research on shielding glasses, 4 series of radiation shielding glasses were engineered and characterized, promoting local resource utilization, reducing reliance on imported materials, cost-effective solution compared to the one that you import, and we have got some scientific contribution from this research. We have got produced 4 articles in 2 journals. The first one was that compared that one is synthesis and characterization of rice hulls and palm fruit bond fiber. That one is comparison between the silica that was extracted from rice hulls and palm fruit bond fiber. The second one is bismuthite and cassiterite, blah blah. The bismuthite there is bismuth O. Cassiterite, tin O. Glasses, food. Then optoelectronic and gamma shielding property of blah blah. All these are Q1 articles. The first 3 there, the 2 there are for the series number 1, but the last one is for the most transparent glass, which is the one that was produced using what? Using glass. Optophysical, microstructural, X-ray, and gamma ray attenuation efficiency of all driven tin and bismuth glasses reinforced with barium oxide. That is our contribution to the body of knowledge from our research in glasses, radiation shielding glasses. Vice Chancellor, sir, distinguished agents, this marks the end of our research on materials, mineral-driven radiation attenuating glasses. The next part of the lecture presents novel solution for space radiation shielding using polymer ceramic composites. Space is an environment that is highly unpredictable and highly radioactive, especially with the flares, what we call the solar particle events. Sometimes the soul will just vomit radioactive, high energy, heavy radioactive materials into space. So if you have satellite and space shuttle in space, you need special shielding for that, for space exploration. There was a story of Nigeria losing one of its satellites, I think 9.1, when it launched into space some years later. Because radioactive cosmic radiation in space will affect the electronic system. If you have electron beam of high energy like 1 MeV entering the electronic system, it will distort it and you will lose the signal. But there is another constraint that we need to work with. Two of them. One is the weight of the shielding material we are using in space. Two is the material should not be, instead of protecting, should not be emitting secondary radiation. Because if you expose some materials to radiation, if they absorb the radiation as in the form of shielding, they will, as a result, emit radiation. So that secondary radiation is what we must avoid. So specially engineered materials like polymer and all composites are being explored for solution for solving this problem in design. My team had developed polymer ceramic multilayer radiation shielding materials and for space exploration. We use high density polyethylene because polyethylene has exceptional impact resistance and durability under excellent conditions. We reinforce polymer composite with this with our mineral wash to see how we'll be able to provide single solution. Vice versa, we engineered dome-leaf reinforced high-density polyethylene and studied the moderate effects induced by moderate gamma irradiation on this polyethylene. So the first part of the design was, okay, when you see dome, so we source Goruba leaf to extract fiber from Goruba leaves and then engineer polyethylene, so plastic, to see, because they don't have weight, to see if we use them as shielding solution in space. Now what we have done in this, the first part of the design, after engineering them, we now say, okay, let's expose them to source of radiation. Gamma sources at the Nigerian Institute for Radiation Protection in the University of Ibadan, to see what will gamma exposure to gamma change some properties. Yes, even from the plot, you will see it's the same material but it's emitting different Fourier transform infrared spectroscopy, indicating some chemical changes. And we concluded with an article that was published this morning by Radiation Physics and Chemistry online that yes, moderate gamma irradiation improves as well as destroy the material. At 100 gray dose, there was improvement in the mechanical properties of the polyethylene. But beyond 100 to 150, you got property degradation as a result of the damage to the lining and cellulose that are contained in the dome fiber. Vice versa, because of the lightweight limitation, we decided to produce what we call multi-layer satellite electronic shielding system. We dubbed it MOLSES, where we use different layers with the polymer we have just produced. We engineered hexagonal boron nitride layer and aluminum oxide nitride. What we did was to study the picture, yes, the first picture by the left, to engineer them and then use particle radiation sources, linear, from the National Hospital, linear generator, to generate electron beams and see how will these materials absorb these electron beams. And the performance was exceptional because we got up to 92 to 98% attenuation of electron beams with these materials. Vice versa, if you remember, This is on the basis that you sent us, myself and Professor Sadiq, to go to NASDA, National Aerospace Research and Development Agency, to sign an MOU. So it is one of the research that we sought at that time to explore with NASA, but we have gone ahead to do it by ourselves. We hope NASA will go ahead. The next, sorry. I hope we take this up. Okay, the last shielding solution we produce vice chancellor, all the hexagonal boron nitride and aluminum oxide that was used in the milk set were imported. We now say, okay, let us look for mineral ore and use to get the same solution. We use plagioscales feldspar, just a piece of granitic looking stone, and then use it to produce the same radiation shielding solution with a layer containing bismuth ore. And after that, the next flow there is of the SRD, that's X-ray diffractivity. Can you go to the next, please? Okay. Conclusively, this material got a very important up to 40 to 60% radiation attenuation efficiency. But what is exceptional is that sample number C has higher linear attenuation coefficient compared to others. This is justifying that layer orientation and arrangement also determines the attenuation efficiency of multi-layer system. This is what we are planning to do with the plagioscales feldspar is that we have thought, let us use it in nuclear reactor environment. But to be able to do that, we need to investigate the mechanical properties or changes induced after irradiation with neutron. And we have sent these samples along with one of our PhD students to the Center for Nuclear Research, Center for Energy Research and Training in Ahmadu Bello Zaria to work with Nigeria's research reactor and generate neutron flux and expose this multi-layer system to see what will neutron exposure cause in the mechanical and other properties of the material. Under multi-layer solution, VCSA, our contribution to knowledge has been well published, about 5 articles, with one of them, the last one, by the left, released online on the 15th, if you see, on the 15th of July, 2025, yes, by radiation, physics, and chemistry. Now, let's explore the research collaboration and investment potential. Nigeria's mineral resource deposits offer a unique chance for research to develop innovative research products. One of them is radiation shielded materials through collaborative efforts. These radiation attenuated products can be used in various fields like in medicine, hospital, aerospace, automotive industry, and this highlights the huge business opportunity that is associated with this type of product-based research. Our policy recommendation, we need to establish special research and product development grants, specifically to support research on solid tolerant valorization. We should provide tax incentive to investors that will help to scale up these research products. And then we need also to develop our infrastructure in terms of research facilities, equipment for testing, and so on. Regulatory framework, we should ensure that products derived from Nigeria's minerals resources, like radiation shielding materials, meet the international standards and are safe for use in various industries. Must also strengthen mining investment funds and cooperation to attract more foreign direct investment. Thank God, the chairman and the president of the Geological Society of Nigeria is here with us, my uncle, Aliyu Salim Malimi. We also need to strengthen domestic beneficiation, where ore that are mined from Nigeria needs to be processed at least 30% before they are exported out of this country. Why? Because that will provide job opportunity and also create value addition. I think South Africa had adopted 25% processing, but 25% processing before you take the mineral that you are mining from South Africa out of the country. We need to engage in signing MOUs between our university, the Federal University in Lafia, a hub for integrity, innovation, and excellence, with the National Agency for Science and Engineering Infrastructure, Nigeria Nuclear Regulatory Authority, and other local industries that is aimed at scaling up these research programs. Conclusion: developing radiation shielding materials using Nigeria's mineral resources can drive sustainable economic growth and development. Developing radiation shielding materials can improve technological capabilities, enabling Nigeria to innovate and adapt to new technologies. Local production of radiation shielding materials can save us our scarce foreign exchange that we have been using to import the shielding materials from other countries. Thank you very much, Vice Chancellor. Yes, Vice Chancellor, sir, I also included from your speech, you said the professor is supposed to tell what is future research. I've included 2 ongoing research works we are doing with my collaborators and postgraduate. One of them is active radiation shielding in space environment using electromechanically cooled superconductor modeling. This is going to be more of theoretical calculation on how to embed or to engineer superconducting magnets into space shuttle that will be able to deflect charged particles in space from reaching the spacecraft. The second one is accident-tolerant cladding solutions in nuclear reactor, where we are trying to develop a material composite containing niobium and silicon carbide for producing what we call the cladding, producing cladding that will protect the nuclear fuel from the cooling water system. Thank you. The next part of the lecture is our acknowledgement. I wish to acknowledge the support and of my research collaborators, which have contributed immensely to this research. But first and foremost is TEFON, Executive Secretary, sir, represented by our distinguished officer here. We acknowledge TEFON for the grant, 25 million naira National Research Fund grant given to my team that has motivated us to achieve this. My research collaborators, with their names there, notably is my co-researcher, Dr. Umar Saad Ali, who is an expert in glass science, and Dr. Abdul Karim Muhammad Hamza, who is also here, Dr. Joseph Delmazira, Professor Muhammad Sulu Suleiman, and my postgraduate students, Amina Dunama, PhD, Suleiman Yano, about to be PhD, Ali Musa Kazayo, MSc, Muhammad Isa Oshafu, MSc, Usu Ayose, she's here too, about MSc, Ruben James Tume, thank you very much. Adamu Ochieno, Emmanuel, thank you very much. My PhD student working with cladding is here, Chidebere Obasi. Thank you very much. And Iwa James Samia is joining us online. He's the person working with theoretical calculation on how to work with superconductor magnets in deflecting charged particles in space from reaching the space shuttle. Special acknowledgement, Vice Chancellor, sir, permit me to read out this as it has been prepared, so I don't want to miss something. Vice Chancellor, sir, I'm deeply humbled to stand before you this awesome audience today at the age of 43 to to deliver this inaugural lecture, making the beginning of this chapter in my academic career. As I reflect on my research endeavors, I am reminded of the profound impact that physics has on our daily lives, from the energy we consume to the environment we inhabit. My journey this podium began many years ago in the quiet town of Kefi, where my paternal grandparents and I were born. I attended the Baptist Primary School Kefi and then proceeded to Government Secondary School Yaba in Abuja, where I laid the foundation for my future academic pursuit. It is hard to believe that it has been 23 years since I left those hallowed halls, armed with the passion for learning and a dream to make a difference. Today, as I'm about to be inaugurated Professor of Nuclear Physics, I am proud to have fulfilled that dream, and I am grateful for the opportunity that have brought me to this moment. I will not be standing here today without the appropriate support and sacrifices of my family. My mother's selfless devotion and encouragement have been a constant source of strength, nurturing my curiosity and passion for learning. My late father's wisdom and guidance have instilled in me the values of perseverance and excellence. I am forever grateful for their love and support. I appreciate the fatherly support of my uncle and foster father, Alhaji Bello Dorma, is here in the audience. Sincere thanks to him and his family. I also wish to acknowledge the pivotal role of the Nasarawa State University in my hometown. In shaping my academic career, the university offered me a job in 2008, 1 year after my graduation, providing me with a platform to grow into the scholar I am today. I am eternally grateful for that opportunity. Furthermore, I am blessed to have two indomitable special friends, my wives, Hajia Nazifa Haruna Muhammad, Hajia Fatima Anura, who have been my rock, supporting me through the ups and downs of my journey. Your love, encouragement, and sacrifices have meant the world to me. To my children, Rahama, Razwan, Ashifa, Ruqayya, Rabi'at Muhammad, Sirin, Aliyu, and Hadara, I thank you for being my most friendly friends. Your smiles, laughter, and curiosity have kept me going, even in the most challenging times. I would like to thank my siblings, Zainab, Amina, Umar, Abdullahi, Sulaiman, Aisha, and Hafsa for their support and prayers. I am a product of the influence of teachers, friends, and family members who have shaped me into the person I am today. I extend my gratitude to all those who have been around me, offering guidance, support, and inspiration. Your impact on my life has been immeasurable. Few among them are my childhood friends, Muhammad, Umar, Ishaq, Muhammad Tahir, Muhammad Shaib Irhan, Muhammad Gambo, Hafiz Shehu Ibrahim, Dr. Ismail Yusuf Ismail, Usman, Professor Abdul Salam Yabu Gitar, Professor Baburo, Professor Ibrahim Khalid Adam, Professor Nasruddin Baba, Dr. Muhammad Abdullah Yab, Umar Ibrahim, Dr. Inusa Ewa, the head of the Department of Physics, National University Kefi, Dr. AZ Loko, Dr. Olatunji Aniola. My sincere thanks go to Architect Bala Ango, Alhaji Bashir Basha, CSA Dr. Yunusa Saidu Madubu, Muhammad Tankolo, my classmate at the Government Secondary School Yaba, our head boy, who is unavoidably absent but will join us online, Mr. Chidoze Ibe, Anyayo Osaze, Bilal Tenimu, Ada Shaibu, Emmanuel Mweke, Ibrahim Zaka, who is with us here, by Michael Obasani. I appreciate it. Hensley, J.A., Architect Hassan Mustafa. Thank you very much. My classmate at the National State University, Kefi, Dr. Kuki Ian, Dr. Omnipide Bamedele, Halima Abubakar Kana, Isa Obabu, Victor Sledaladi, Chaga Christian. I thank you very much for your support. I stand on the shoulders of academic giants, and among them, one individual has played a transformative role in shaping my intellectual trajectory. I wish to express my heartfelt gratitude to my mentor, Professor Muhammad Sunusi Limani, whose visionary guidance, expertise, and unwavering belief in me have been instrumental in my growth and scholarship. Your mentorship has not only shaped my research, but has also inspired me to strive for excellence. I am honored to acknowledge your impact on my academic journey. Our Vice Chancellor, sir, your mentorship, friendship, and prudence has also been an important motivation for me, and I thank you most sincerely for your support. A very big thank you goes to the University Management team for their invaluable support, the Chairman Inaugural Lectures Committee, who is unavailably absent, Professor Josephine Ode, and her members. I thank you people most sincerely. To our indefatigable University Auditor, Professor Ilumuna Adolfo, I thank you most sincerely for the support. Throughout my career, I have been driven by a passion to unravel the mystery of radiation and its interaction with matter. My research has traversed realms of nuclear power, radiation detection, environmental radioactivity, and radiation protection. Today, we have journeyed through a fascinating landscape of nuclear and radiation physics, and we explore the intricacies of radiation shielding, its application, and its implications. I am also indebted to my PhD supervisor, Emeritus Professor Ahmad Tirmizi Ramli of the University Technology Malaysia, whose guidance, expertise, and support have been instrumental in shaping my research and academic trajectory. I also send a very big thank you to my MSc supervisor, Professor Emmanuel Hembe Aga of the Benue State University, Makodi. I thank you for your mentorship, sir. To all my teachers at every level of education, from primary school to university, I extend my heartfelt gratitude for your dedication, inspiration, and wisdom. You played a significant role in shaping my intellectual curiosity and passion for learning. I have listed a few out of hundreds of great men and women who have imparted on me. Professor Mikaela Omar Buku, Professor Williams Lumbi Lucas, Dr. Abdul Karim M. Umar, Professor M.O. Aliyu, the man who taught me physical chemistry, the Dean, Faculty of Physical Sciences. Thank you very much, sir. Professor Lucas, Professor S.X.K. Boas, Professor Johnson Fatuku, Mr. Hussein Ndako, and others. I thank you people very well. I would like to express my sincere appreciation to my colleagues, both teaching and non-teaching in the Department of Physics, Federal University Lafia, for their support and collaborative spirit. Your friendship and expertise have made my academic journey richer and more fulfilling. Special thanks goes to the head of the department, Dr. J.A. Bani Kole, Professor O.J. Abimbola, Dr. B.J. Falai, Dr. Aisha Ademu Bello, Dr. Mrs. Rebecca Ofo, Dr. Joseph Omodola, Dr. Oyakachi Kalu, Dr. Adewumi Tayo, Dr. Adejo Muhammad, Dr. Ahmad A. Sule, the council member, Mr. Abubakar, Mr. Faisal, Zahara Muhammad Sanusi Liman. I thank you all. I am deeply grateful to Professor Eno James Ibanga and his wife, whose encouragement and support played a vital role in my academic journey. Notably, Professor Ibanga's wife kindly assisted me by typing my graduate assistantship application letter to Nasarawa State University, Kebbi, an act that marked the beginning of my path towards becoming a professor. Thank you, ma'am. Thank you, sir. It is worth mentioning that Professor Eno James Ibanga is currently the Commissioner for Education in Akwa Ibom State. I would like to specially thank my research collaborators for their support. Among them, Dr. Umar Saad Aliyu, Dr. Abdul Karim Muhammad Hamza, these are the glass experts, Dr. Muhammad Sani, all of the Department of Physics, Lafia, Professor Timothy Mosiu of University of South Carolina, Dr. Benga Bivan Yapuma of Northeastern University, Gombe, Dr. Muhammad Mukhtar, Dr. Joseph Dilama Zira, Professor Umar Ibrahim Gaya of the National Agency for Science and Engineering Infrastructure, Dr. Nuruddin Nasir Garba, Department of Physics, Ahmadu Bello University, Zaria, Dr. Hammatukul Gabdo of Nigeria Atomic Energy Commission, Professor Munir Aziz Salim of the Department of Nuclear Engineering, University Technology Malaysia, Dr. Aminu Ismail Department of Physics, ABU Zaria, Professor Joseph Dada, Professor Nicola Evangeli. To my great postgraduate students and mentees, I am proud of the scholars you have become and the research we have undertaken together. Your enthusiasm, creativity, and hard work have inspired me to continue pursuing the boundaries of knowledge. You all played important roles in this lecture, and your effort is appreciated and acknowledged. Dr. Amina Dunama, Jibril Yaro Suleiman, Ali Musa Kazayo, Muhammad Isa Oshafu, Emmanuel Obuche Chidebere Obasi, Iwa James Samia, Adamu Emmanuel Ochoyo, Luben James Utume, Ngusu Scholastica, my uncle and mentor, the president of the Nigerian Society, of the Theological Society of Nigeria, Mr. Uba Salim Malemi. I thank you for your support and your words of encouragement. I want to express my deepest gratitude to my family, to the family of late Mr. Patrick Onoja. Sir, permit me to share with you a nostalgic moment. I have a letter, most importantly, may his soul rest in peace. Baba Patrick Onoja is an uncle to my mother. And he played a pivotal role in my journey to becoming a professor. His letter, dated 26 April 1986, addressed to my father, was revolutionary, emphasizing the significance of education in our lives. I, on behalf of my siblings and my family, thank you for the show of love and support. I appreciate the unwavering support of my in-laws throughout this journey. Their wishes of well-being and prayers have meant the world to me. I extend special appreciation to the chairman and members of First Lafia All-Stars that are here to support me. Vice Chancellor, permit me to chant our slogan for togetherness. All Stars, oye! All Stars, All Stars, All Stars. I am deeply thankful to members of the Federal University Lafia Senate, our distinguished professors, provosts, colleges, deans of faculties, head of various departments. I thank you all. To the members of Full Lafia Community, Executive Council, Legislative Council that are here with us, I thank you very much. Executive Secretary Tekfo, I thank you for the support and the prayers. Executive Chairman, KF Local Government, Dr. Idris Zamagani, we served together in Bayelsa. I call him Kajiyana, the Sadiq Prof. Thank you very much. Director General, National State Human Capital Development Agency, Habibur Suleiman Balarabe, I thank you very much. His Royal Highness Emir of Kefi, Alhaji Dr. Shehu Chindo Yamusi III, I thank you. Vice Chancellor, National State University Kefi, Rector Isa Mustafa Agway, the Third Polytechnic, our newly appointed, printed and minted Rector, Dr. Nuruddin Mefata, thank you very much. Rector of College of Agriculture, Science and Technology, Lafia, Dr. Mekefi, I thank you very much. The President, Nigeria Institute of Physics, the President, Nigeria Society of Physical Sciences, and my uncle, the President, Geological Society of Nigeria, I thank you guys very much. Nuclear-related agencies that have sent representatives here, NAE and the NNRA, I thank you very much. There are business leaders who have supported me. Chairman Yusal Nigeria Limited, a group of companies. The Chairman UYK Nigeria Limited. Chairman Zabati Group. Chairman Cabs and Partners. The Chairman Progressive Educational Services. Chairman Amboson, Architect Bala Ambo. Managing Director, National Investment and Development Agency. Academics that have come to celebrate with us here. Professor Ali Adil of the Joseph Taka University of Agriculture Makodu is here with us. Professor Baba Alfa of Ibrahim Badamasi Babangida University in Apai. Professor Shehu Usman of the Department of Sociology, National State University, Kefi. Professor Umar Shehu Usman, thank you very much. Head of Department and staff of the Department of Physics, National State University, Kefi. Ahmadu Bello University, Zaria, and Usman Danfodio University, Kefi. Sokoto, thank you very much. Our esteemed guests, distinguished visitors, friends, associates, family members, head and personnel of security agencies, technical crew, university information units, members of press, ladies and gentlemen, you are all special people and you deserve a special mention. You are in my thoughts, and I am sincerely thankful to all of you for the support and prayers. Thank you all.
Thank you very much. Round of applause for Professor Abubakar Sadiq Aliyu. Congratulations, Prof. May I invite the chairman of the occasion, Professor Shiu Abdurrahman, to present a gift to the inaugural lecturer. The wives of the inaugural lecturer can please join him on stage.
Faculty of Physical Sciences, Certificate of Merit, Award to Professor Abubakar Sadiq Aliyu, Professor of Nuclear Physics, Department of Physics, on the inaugural lecture presentation. Today, 16 July 2025. Congratulations. This is a symbol to show that Professor Abubakar Sadiq Aliyu has presented his inaugural lecture today in Federal University of Lafia, which is an indication that he's now inaugurated as professor of Federal University of Lafia. Usually, in this university, if anybody calls himself professor, you go to his office, you didn't see this. That person has not been inaugurated. So, congratulations. I was told this is heavy, but thank God we have two wives here. This is a gift from the committee of inaugural lecture in this university. Thank you.
Thank you very much, sir. Once again, congratulations, Professor Abubakar Sadiq Aliyu. As a chairman, I would like to invite Dr. Susan Dimba for the vote of thanks.
Vice Chancellor, Federal University. Our Senate members, eminent scholars seated, my senior colleagues, co-colleagues present, our invited guests, dignitaries, our students, ladies and gentlemen, thank you for making this to yet another fascinating and exciting event. In adherence to one of our tradition of staging an inaugural lecture, And as the 31st series of such an insightful analysis is indeed a plus to this great institution. Please let's appreciate it. This is also evident that the chair of this noble committee, Professor Josephine Ode-Inasi, have not related in any way. Many thanks to her in absentia, and many thanks to the presenter, Prof. We have gained a lot from your presentation. Congratulations once more. To our technical crew who have been working tirelessly, ensuring this is well projected, you are held on a high esteem. We say thank you. And as we look forward to seeing more of you, we say thank you. Please, as you go back to your various destinations, our prayers are with you. May you go well. Please permit me to take a few announcements before we pray individually. Then we call it a day. I'm asked to inform you that the presenter, that's the Professor Sadiq, will be having a refreshment with his guests at the First Crown Luxury Hotel, AA Sule Street, GRA, after we part from here. Thank you very much.
Thank you very much. Mr. Chairman, distinguished ladies, and I will be guided by the protocol officers of the university. On this note, Mr. Chairman, distinguished guests, we've come to the end of the 31st Inaugural Lecture Series of the university. We look forward to seeing you here again in subsequent and close this event with prayers and different things. Amen. Thank you. We wish you join us back to your various destinations. We thank you. We thank you. We thank you.
an jima ana tare, mutumin kirki ne, bawan Allah wanda mun jima muna tare da shi. Wannan lamari da Allah ya kai shi muna tashi farin ciki. Allah ya taya mishi, Allah ya bashi nasarar rayuwa har bayan baya da iyalai gaba daya. Allah ya tada alheri. Abinda aka yayi ilimin shi Allah sa a girba take kawo fuska insha Allah.